Welcome back, ladies and gentlemen. Our focus today, we are going to continue our work on nomenclature, specifically talking about ionic compounds and how we name them. So we're going to be able to identify what types of elements are involved in ionic compounds and then be able to appropriately name them. So should be a good time. Let's go ahead and move forward. So hopefully by the end of this video, you'll be able to understand how chemical formulas are written, explain how charges determine the structure of chemicals and how many atoms are involved in each particular chemical. You should also be able to write out the formula of the chemical name and vice versa, be able to get the chemical name from the formula. So let's get started. But before we get started, we're going to talk about some key vocab terms here, that being chemical formula. We'll talk a little bit about subscripts, monatomic ions, the term nomenclature, as well as polyatomic ions. So in regards to chemical formulas determine the number and the type of atoms in a compound. So if we look at the example here on the right, we have water, which contains 2 hydrogen atoms and 1 oxygen atom. These are indicated by what are known as subscripts. The subscript 2 indicates that there are 2 hydrogen atoms inside of a molecule of water. When we have just 1 atom inside of a molecule or a compound, we do not use a subscript. The lack of a subscript implies that there's just 1 atom that is there. So hopefully you get the idea here. Again, it's all about the subscripts. The subscripts determine the number of atoms that are found inside of a compound or molecule. Now, the term monatomic ions are ions that are formed from a single atom. And the reason these are formed is based on the number of electrons that it either gives or accepts in order to get to that octet rule we talked about earlier. So for example, Mg with a 2+ charge indicates that it's going to lose 2 electrons in order to become stable. That's why it has a 2+ charge. It contains 2 more protons than electrons. It has lost those 2 electrons. Same thing with fluorine. With a minus charge, it indicates that it's going to gain 1 electron to become stable. That's why it is F-. It has a minus because it has 1 more electron than protons. And you can see a couple more examples over here on the right. We've got sodium, potassium, silver, and copper with a +1 charge, meaning that they will lose an electron in order to have an octet in their outermost shell. Magnesium, calcium, strontium, nickel, iron, copper will lose 2 electrons, and aluminum and iron will lose 3. And so on for the ones down at the bottom, except they're going to gain those electrons rather than lose them. Now, how do we know these charges? Well, the charges are determined based on their locations on the periodic table. We've talked a lot about valence electrons and how it's important for chemicals to be able to have 8 valence electrons in their outermost shell. So the periodic table really helps us understand how many electrons are either needed to be gained or to be lost in order to satisfy the octet rule. So if you look at the first column there on the left, the alkali metals, all of them really want to lose that 1 electron in order to have a stable outer shell. Similar to the alkali earth metals, except they want to lose 2. If we go all the way on the far right-hand side of the periodic table, we have our noble gases. And they don't want to either gain or lose electrons because they already have 8 valence electrons in their outermost shell. The column to the left of that, the halogens, only want to gain 1. Next to that, they only want to gain 2, want to gain 3, etc. So the charges help us determine how many electrons are needed to satisfy the octet rule. Now, classification and naming of these compounds is known as nomenclature, and they can really be broken down into 3 types. We're going to talk about type 1, type 2, and type 3. Type 1 nomenclature is as follows. With type 1 nomenclature, we're only going to deal with compounds that are ionically bonded. So we're dealing with ionic compounds. And what we're looking at is metals chemically bonded with non-metals. But we're looking at specific types of metals to start off with. So what we're going to be looking at are the first 2 columns. Aluminum, gallium, zinc, and silver. So we're going to look at all of these metals and how they bond with nonmetals. We'll talk more about how these metals work in a later video. So how do we know how to write ionic compounds? Well, the one thing we need to keep in mind is that the total net charge of all of the compounds must equal 0. So for example, sodium has a +1 charge and chlorine has a -1. The +1 and the -1 cancel each other out to leave a net charge of 0, therefore we just write NaCl. Now if the charges do not balance out, then we add atoms on either side in order to balance out the charges. So for example, calcium is a +2 and bromine is a -1. Well, +2 and -1 do not cancel out to equal 0. So in order to correct that, the chemical formula is going to have two bromines. Two bromines, each with a -1 charge, is equal to -2. So Ca will be +2, and each bromine is a -1. So in order to balance that out, our chemical formula written correctly is CaBr2. You'll find that we will utilize these concepts in order to balance many of the different compounds in order to get the net charge in order to equal 0. But there's actually a little shortcut on how to do this that I'm going to show you here in the next slide. So how does this process work? Let's say we wanted to know the formula for a chemical containing magnesium and chlorine. Well, we write out the symbols. So first we write out Mg and Cl, and then we determine the charges based on the location on the periodic table. So what we look at is we know that Mg, based on where it is on the periodic table, has a 2+ charge, and chlorine has a -1 charge. So what you do then is you cross the absolute value of your charges and check that they cannot be reduced. So the total charges must be equal to 0. So we crisscross our charges, so the 2 from Mg will go down into the subscript of Cl, and the 1 from Cl will go down into the subscript of Mg. But remember, we don't show 1s as subscripts. So the chemical formula here is MgCl2. Okay, let's explain that a little bit more when we do some practice problems. Write the formula for the following compounds: magnesium sulfide, aluminum bromide, and sodium nitride. Well, let's break these down. Magnesium is Mg. Sulfide refers to sulfur S. Let's take a look at our periodic table and determine the charges. Mg is a 2+, and sulfur is a 2-. Now, again, in a compound, our charges have to balance out to equal 0. In this case, the +2 cancels with the 2- because their charges cancel out with one another. So our formula is just going to be MgS. So that's magnesium sulfide. Let's look at aluminum bromide. Aluminum is Al, bromine Br. The charge on aluminum is a 3+, and bromine is a 1-. Now, a couple ways you can look at this. I need these to balance out to equal 0. Therefore, I'm going to need 3 bromines to cancel out the +3 charge of aluminum, because each bromine has a -1 charge. Or you crisscross the absolute value of your charges. So the 1 is going to go down here, the 3 is going to go down here. So what I get is AlBr3. And that's my formula. Let's do one more. Sodium nitride. Sodium is Na. Nitride is N. I look at my charges. Na is a 1+, N is a 3-. Again, to balance out our charges to equal 0, I am going to need 3 sodiums to balance out the -3 of nitrogen. Or, again, we crisscross the absolute value of our charges. So what we get is Na3N. And that's my chemical formula. All right? So again, the key things here: find your elements on the periodic table, understand what their charges are, and balance out those charges in order to obtain 0. Like I said, you could do that by looking at them and figuring out how we're going to get them to balance, or we crisscross the absolute value of our charges. Either way, you hopefully will get the right answer. For the next set of problems, we're going to go from formula to name. So we're going to go in kind of the opposite direction. A little bit easier here, I think. Identify which elements are present in your compound. Pretty straightforward. Use the full cation name with the trunk of the anion and ide added. So the very first part, we just call it whatever element it is. It's pretty straightforward. Whatever the cation is, we take the trunk of the name and add ide, chloride, iodide, bromide, nitride, sulfide, etc. Okay? Let's try some practice problems together. So first one we're going to look at is AgCl. Well, Ag is silver, and Cl is chlorine. We write our root, our stem, chlor, and then we add ide to again it. So this is silver chloride. Our next one, CaO. Ca is calcium. O is oxygen. But we're going to add ide. So it's going to be calcium oxide. The last one, Al2S3. This is aluminum. And S is sulfur. But again, we use our root, we use our stem, it'll be sulfide. Okay? So I think naming these ways is a little bit easier. Going the other way, you'll understand it. It just takes some practice in order to get a good understanding of it. Now, some ions have more than one atom, and these are known as polyatomic ions. They don't end in ide, but they've been given specific names. So if you look at the examples on the right here, some very common polyatomic ions are nitrite, nitrate, cyanide, hydroxide, chlorite, chlorate. You'll see these and start to recognize these as you continue to use them more and more. Now, these act as a single ion. Even though they are comprised of more than one atom, they act in a similar way as the monatomic ions do. Okay, so they each have their individual charges associated with it. When you balance them out, you treat them as if they are just one entity, as if they are very similar to a monatomic ion when we name them. Okay? So let's get some practice with some of these as well. Write out the formulas for the following compounds. So we are going from name to formula here. So let's take a look at this. The first one is aluminum sulfate. Aluminum is Al. Again, we look at our periodic table for our charge. That's going to be a 3+. Sulfate, notice it doesn't end in ide. That really gives away that this must be a polyatomic ion because it doesn't end in ide, it ends in 8. You notice that the other three here end in 8 as well. 8 is common, ite is common. You get the idea here. So sulfate, if we look at our chart, is SO4 with a -2 charge. Okay? Now our whole goal here again is to balance these out to equal 0. So what you're going to find is that we will need to crisscross the absolute value of our charges. So again, we're going to take the 3 and bring it down here, and the 2 and bring it here. So this is going to be Al2. Now when you have multiple polyatomics, you keep the polyatomic ion the same. You put it in brackets, but the 3 drops down after the brackets. So this tells us that I have 2 atoms of aluminum and 3 of the polyatomic SO4 ions. Okay? So that's how you would write this chemical formula. It is Al2, SO4, 3. Let's look at barium nitrate. Barium is a 2+2. Nitrate, NO3, is a 1-. So again, we crisscross our charges. We have to balance these out to equal the charges out to equal 0. So this is going to be Ba NO3 2. Okay? So again, the 2 goes down here and the 1 goes down there. The last one is sodium phosphate. Sodium is Na, and it has a charge of +1. Phosphate, if we look at our chart, is PO4, and that's going to have a -3. So again, the same rules apply here. We need to get these charges to balance out to equal 0. So the 3 will drop downstairs here, the 1 here. So this is going to be Na3. And since we only have one polyatomic ion, we don't need to put it in brackets. So it's going to be Na3PO4. All right? Write out the names of the following formulas. This is actually a bit easier because you don't even need to change anything to ide or anything like that. We just name them as they are. So the first one there, Sr, NO3, 2. Sr is strontium. And NO3, if we look at our chart, is nitrate. The second one here, CaSO4, Ca is calcium. SO4 is sulfate. Third one, NaOH, Na is sodium. And OH, if you look at our chart, is hydroxide. Practice makes perfect with these guys. We'll continue to practice with these types of problems, and hopefully you'll be experts at naming chemical compounds here in a little bit. So some tips from Lamb. Some tips from me. First off, I would identify the type of ion first. Is it a cation? Is it an anion? Does it typically have a positive charge? Does it typically have a negative charge? Keep in mind that the cation always is written and described first. So if we had something like sodium and bromine, sodium is your cation. It must come first in our chemical formula. Our positive charges always come first. So you'd write that as NaBr, not BRNA. Remember that polyatomic ion subscripts do not change. Remember, if we have SO4, it will remain SO4. Even if we have multiple of those compounds, it's still SO4. We would just put it in brackets and then put however many SO4s we would have as a subscript underneath that. And don't skip steps. I would say that's very important. Take things one step at a time until you become more proficient at performing these types of problems. So hopefully you understand a little more about the rules of naming chemical compounds. Again, long story short, identify your charges of your atoms, cross the absolute value of your subscripts, and reduce those subscripts if necessary. Keep in mind that polyatomic ions have more than one atom but also act as a single ion. Also remember that when you're naming monatomic ions, you use the full name of the first atom. Whatever the second atom is, you use the stem and add "-ide" to it. Hopefully you understand the learning targets. We'll come back to class and talk a little bit more about this next time. Have a great day, guys. We will talk to you later. Bye-bye.